Hey everyone, it's Justin again, back for another quadratics lesson, the quadratic formula part 2. In this lesson, we'll learn how the discriminant of quadratic equations can tell us how many solutions an equation has. We'll also practice solving some more quadratic equations with the quadratic formula, but this time they might only have one solution. Do you have your PDF ready and your calculator within reach? Let's get into it. So last night I was practicing solving quadratic equations using the quadratic formula, and I got stuck on this problem. 3x squared plus 6x plus 6 equals 0. This is how I typed it into my calculator. By the way, to make it easier to type in, I went ahead and multiplied the numbers in the denominator to get 6. Anyway, every time I type it into my calculator, I get this error message. I'm certain I'm typing it incorrectly, and the calculator shouldn't be broken. I just got a new one. Can you try it on yours to see if you get the same thing? Pause here to do that now. Did you get an error message too? Why do you think that's happening? Maybe if we work through the equation step by step and we use our calculators for each part, we'll be able to figure out exactly which part of the formula is causing the error. Grab your calculator and let's walk through this together. Okay, so first up is the denominator grouping. 2 times 3, which is 6. No error message there. Moving up to the numerator, we need to simplify the grouping inside the radical symbol. 6 squared minus 4 times 3 times 6. Do you get an error message when you type that into your calculator? I got negative 36. Still no error message. Next is the square root. So the square root of negative 36 is... there it is, the error message. So it's something about this square root that's causing the issue. Any idea what the problem is? What do we already know about square roots? Finding the square root, or the opposite of squaring a number, is basically like asking what number multiplied by itself equals the radicand. So let's say we want to find the square root of positive 36. We know that 6 times 6, or negative 6 times negative 6, equals 36. So the answer to the square root of 36 is negative 6 or 6. If that's the case, then why are we getting an error when we try to calculate the square root of negative 36? Well, is there any one number that, when multiplied by itself, equals negative 36? To get a negative answer, one of the factors has to be positive while the other is negative, like positive 6 times negative 6, which are two different numbers. Since there isn't any one number that can be multiplied by itself to give us negative 36, that means the square root of negative 36 won't have any real solutions. In fact, the square root of any negative number will result in no real solutions. Oh, good catch, Mia. There aren't fake solutions, but there is such a thing as imaginary numbers. No, I'm not kidding. Imaginary numbers are a real concept, but we'll learn more about those in Algebra 2. So, what does all this mean for our quadratic equation here? Well, since there's no real solutions to the square root of negative 36, we're kind of stuck. And since we can't go anywhere from here, that means this equation has no real solutions. In the quadratic formula, this section under the radical symbol, b squared minus 4ac, is called the discriminant. It tells us how many real solutions a quadratic equation has. If the discriminant is positive, or greater than 0, then this square root chunk of the formula will have a positive and a negative answer, which is why the formula has the plus or minus symbol built in. So when we continue simplifying the equation, we will end up with two real solutions. If the discriminant is negative or less than 0, then the square root chunk won't have any real solutions, so the equation won't have any real solutions. But something's missing here. What if the discriminant is equal to 0? Let's say we're using the quadratic formula to solve an equation, and we end up with the square root of 0. What is the square root of 0? What number multiplied by itself equals 0? Well, there's only one answer here, 0. So if this chunk with the square root symbol simplifies to 0, whether we add or subtract 0, the numerator of the equation will still simplify to just negative b, leaving us with only one solution. Since the square root of 0 has only one answer, that means the quadratic equation will have only one real number answer. Let's try using the discriminant to predict how many real solutions a quadratic equation will have with some example problems. Here we have negative x squared plus 10x minus 25 equals 0. And we need to calculate the discriminant to determine how many solutions the equation has. What do you think our first step should be? Just like when using the full quadratic formula, the first thing we need to do is determine what our a, b, and c values are. Take a moment to identify the a, b, and c values for this equation. In this case, a is negative 1, b is 10, and c is negative 25. Pause here to substitute the values into the discriminant and simplify. After substituting in the values, we have 10 squared minus 4 times negative 1 times negative 25. Don't forget to use those parentheses when substituting so we can keep track of any negatives. 10 squared is 100, and negative 4 times negative 1 times negative 25 is negative 100. 100 minus 100 is 0. If our discriminant is 0, how many solutions will this equation have? Remember, in the full quadratic formula, the discriminant is the chunk under the radical. And with the plus or minus symbol here, whether we add 0 or subtract 0, the numerator will still have the same value. So as a result, the equation will have only one solution. Go ahead and try these next two by yourself. Calculate the discriminant and use that value to determine how many solutions the equation will have. Did you notice that the equation for problem number 2, m squared plus 7 equals 12m, is not in standard form? We're going to need to do some rearranging before we can start substituting our values. After subtracting 12m from both sides, we can identify our a, b, and c values, and then substitute them into the expression. After simplifying, we're left with 116. 116 is greater than 0, so this equation will have two real solutions. And what about the third problem? After substituting in the values, we have 2 squared minus 4 times negative 8 times negative 3, which simplifies to negative 92. How many solutions will this equation have? The discriminant value is less than 0, so this equation will have no real solutions. Now that we've tried those examples, let's take a moment to summarize some of what we've learned. Calculating the discriminant of quadratic equations can be super helpful when deciding on how to solve them. For example, if the discriminant is 0 or is a positive perfect square, you may be able to solve it by factoring. positive discriminants that are non-perfect squares may be easiest to solve by using the quadratic formula. And if the discriminant is negative, then that indicates that the equation has no real solutions, so you've already got your answer. And since the discriminant tells us how many solutions we should have, we can also use it as a tool to check our work. Let's use what we've learned about the discriminant and apply it to some familiar problems. Just like we did in the previous lesson, let's solve some equations using the quadratic formula, but this time we'll use the discriminant to help along the way. Here we go. We have the equation 3w squared plus 6w plus 3 equals 0. Pause here to calculate the discriminant to determine how many solutions the equation has. Then, if the equation has any real solutions, use your preferred method to find them. So, how many solutions will this equation have? The discriminant is 0, so it will have one real solution. Now that we know how many solutions to expect, we can solve. You may have noticed that you could factor this equation, and if you did, your work may have looked something like this. Notice how both factors of this expression led us to the same answer of -1, proving that this equation has one real solution. Or maybe you preferred solving using the quadratic formula. If you used that method then, after substituting the a, b, and c values into the formula, you should have ended up with an equation like this. In the denominator grouping, 2 times 3 simplifies to 6, and then within the numerator grouping, we need to simplify the grouping under the radical symbol, which, from calculating the discriminant, we already know equals 0. The square root of 0 is 0, and the 6 inside the parentheses becomes -6. This is where, because of the plus minus symbol, we would normally split our equation into two separate equations. But whether we're adding 0 or subtracting 0, the numerator is still going to simplify to -6. So you can split it into two if you want, but it's not really necessary. From here, all that's left is division, which gives us our final solution of -1, the same answer we got by factoring. We can also feel confident that our answer is correct because we ended up with one real solution, which is what we predicted earlier by calculating the discriminant. Last problem, 4g squared minus g equals -10. Calculate the discriminant to determine how many solutions the equation has. Then, if the equation has any real solutions, use the method you think will be the most efficient to find them. Pause here and we'll check your work when you're done. After rearranging the equation to standard form, we have 4g squared minus g plus 10 equals 0. After substituting the a, b, and c values into the discriminant, -1 squared minus 4 times 4 times 10 equals -159. Based on this discriminant value, how many solutions does this equation have? Since the discriminant is negative, the equation has no real solutions. And since the equation has no real solutions, there's nothing to solve for, so we're done. Calculating the discriminant of quadratic equations helps us to know how many real solutions the equation has. If the discriminant is greater than 0, the equation will have two real solutions. If it's equal to 0, the equation will have one real solution, and if the discriminant is less than 0, the equation has no real solutions. We can use this information to decide how to solve the equation and check our work. Once you finish up your guided notes, there's an activity in your PDF and the online practice. There's also 2 bonus activities you can complete if you'd like some extra gold. Whether they're real or not, keep searching for solutions, and I'll see you next time.